Hi, my name is Jonas Austerjost, and I'm a research scientist at the Corporate Research Division of Sartorius, where I'm focusing on digital bioprocessing and the introduction of digital lab tools to improve the efficiency of laboratory workflows. Thanks to the SiLA organization for organizing this conference and giving me the opportunity for this presentation with the title Flexible Automation in the Lab, Driving Efficiency Change, which will introduce emerging concepts in laboratory automation and their impact on overall productivity. Our current data situation is characterized by a happening called data explosion. According to Tensa et al., we are facing a worldwide generation of data which will increase by a factor of 5 from 33 zettabyte in the year 2015 up to 175 zettabyte in 2025. And to put these numbers into context, if each gigabyte in a zettabyte was a brick, 258 Great Walls of China could be built out of 1 zettabyte. Several studies estimated the amount of unstructured data is in the range of 70 to 80%. Furthermore, all scientific disciplines face what is known as replication crisis, in which a majority of experiments lack reproducibility. One interesting example of this was highlighted by Roche et al. In 2015, in which 100 scientific datasets were analyzed with respect to reproducibility. The final research statement indicates that 65 studies lack required information or data, which leads to a state in which experiments are not reproducible by other parties. The entire biopharmaceutical industry is currently striving for an efficiency boost in all their R&D manufacturing facilities and workflows, and increased reproducibility across all facilities and departments, including CMOs, a general decrease of development and production costs of pharmaceutical active compounds while speeding up the time to market, a seamless technology transfer from research facilities and scale directly into the manufacturing and production environment with a general right first time attitude. The biopharma industry will continue the expansion from small molecules to a wide range of large biologics and biosimilars, which are a lot more complex. Just to highlight this, a small molecule like aspirin consists of 21 atoms, whereby the hormone somatropin consists of 3,000 atoms. The monoclonal antibody Herceptin consists of 25,000 atoms. To put this into everyday perspective, it is like comparing the complexity of a small bike to a car and a business jet. It can be said that the increased complexity goes along with higher development and also manufacturing costs. This requires a change of R&D and manufacturing processes to be supported by a data-driven, guided decision-making. Within Sartorius Corporate Research, we have identified several capabilities that are able to tackle the biopharma demands. These capabilities include a unified data handling approach, in which a unified data interface is provided for all kinds of data like videos, images, or spectral data, including scientific data standards. Additionally, the establishment of a paperless infrastructure leading to paperless workflows. A seamless integration of modern and intuitive DOE methodologies and data-driven approaches, including machine learning. The introduction of smart and user-friendly human-machine interfaces to reduce overall complexity. Bringing plug-and-play capabilities into the laboratory and manufacturing environment to reduce setup and automation efforts. Furthermore, enabling hands-free work by introducing voice-enabled documentation and control. Finally, the flexible automation concept was identified as an enabling technology to tackle the biopharma demands. This concept enables the cooperation across different unit operations, like a continuous connection of upstream and downstream processes, as well as shuffling and modification of equipment types, including the scale and throughput in pharmaceutical production plants. These principles also apply to software components or services. In this presentation, the focus is on the underlying technologies which lead to the flexible automation of workflows. These technologies include a unified data handling by relying on unified data standards and precisely defined ontologies and vocabulary, and advanced human-machine interaction, which can be reached by introducing simplification elements that provide an intuitive interaction, and finally, plug-and-play capabilities, which include a unified communication standard with seamless discovery of services. First of all, I want to talk about the plug-and-play concept in laboratory automation. Plug-and-play consists of a specified way for service discovery, which includes a formal description of the service capabilities, as well as a standardized way for exchanging information. This is already common in industries like consumer electronics or home automation. For example, the automated discovery and usage of printing devices or the usage of network speakers, for example, when listening to music over streaming service. As you all know, the standardization in laboratory automation, SiLA, is the leading solution provider for this in the laboratory. The SiLA 2 standard is currently evaluated within the Sartorius Corporate Research Vision. In an initial approach to evaluate the SiLA 2 standard, we have established a SiLA 2 gateway for a couple of devices, which includes devices from our own portfolio, such as a balance, as well as custom sensors based on open hardware. These installations were established based on available reference implementations and evaluated using the SiLA 2 browser provided by Unite Labs. In a subsequent step, we have developed a SiLA 2 feature framework, which is able to parse XML-based SiLA 2 feature definitions. Based on these definitions, an ad hoc SiLA 2 server can be instantiated. Each command and property is implemented by a random handler. These handlers deliver random results according to the specification. This allows us to generate virtual devices that can be used for testing and exploration purposes, for example, orchestration or building up of automation pipelines. On top of these functionalities, we have set up a generic SiLA 2 browser, which is able to show and trigger all devices and their corresponding features. This further includes all available information present in the SiLA 2 feature definition, such as maximum or minimum values. Furthermore, all feature entries, including properties and commands, are automatically mapped to REST endpoints, which allows further adoption into a variety of platforms, such as standard business intelligence tools. A step towards would also include the implementation of a data standard to reach true end-to-end integration. While a communication standard like SiLA 2 specifies how to identify and communicate with a service, a scientific data standard specifies the structure and content of data that will be generated. These data standards provide a vendor neutrality which is especially useful for long-term archival of scientific datasets. Additionally, they enforce an agreed vocabulary and meta richness, which directly enhances reproducibility. They can be seen as an enabler for generic data handling, in which pre-built data manipulating components can be composed to form a holistic data wrangling pipeline. This is in contrast with the current case-by-case way of handling data processing due to non-agreed standards. Currently active initiatives include the work around the allotrope framework, the unified data model proposed by the Pistoia Alliance, and the analytical information markup language, ANIMAL. Exemplarily, I want to give a very short introduction into the analytical information markup language. The ANIMAL data format is a scientific data standard which introduces a meta-rich and vendor-neutral format for storing analytical and workflow data. ANIMAL also relies on well-established technologies which include the open packaging convention and the extendable markup language. ANIMAL comes with two distinct schemas. The ANIMAL core schema enforces the structure of ANIMAL documents, like the experimental steps, used and produced samples, or digital signatures. Further, the animal technique schema provides a specification of a used method, including all required parameters. Such a technique restricts and enforces the use of animal document components, which results in a clear and defined set of data. According to the animal organization, the standard already provides a large ecosystem and fully supports the FAIR principles, which were introduced by Wilkinson et al. In 2016. In general, the acronym FAIR is a hot topic to increase the value of scientific data. FAIR stands for findable, accessible, interoperable, and reusable, and basically reflects the need for a commonly agreed and open vocabulary and rich set of supporting metadata. Overall, it can be said plug and play paves the way for rapid prototyping of manufacturing and R&D pipelines and enables the unification and harmonizing of software islands. By using plug and play and scientific data standards, generic applications are likely to become a reality. This concept covers the establishment of one overarching application to establish, control, process, analyze, and interpret laboratory workflows and data while being independent from device type and properties. For the biopharmaceutical industry, imagine setting up a bioreactor which is capable to directly discover and integrate connected third-party probes and analytical devices. Typically, this integration task takes a lot of effort and know-how and may be minimized by using the introduced concepts. Furthermore, generic applications can be equipped with intuitivity by introducing low-coding technologies like visual programming approaches. Visual programming allows non-software engineering experts to create complex workflows without using actual code by providing graphical components with a dedicated functionality. These components can be composed to finally form an entire workflow of data manipulation, charting, or automation processes. This democratizes automation tasks, allowing every laboratory scientist to perform IT automation work and provides an easy way for a variety of data-driven tasks like explorative data analytics. Two major players in this field are the NIME analytical platform, where workflow is shown on the top right side. It is mainly used for data processing, wrangling, and data analytics, while the Node-RED environment on the bottom right is capable of wiring different hardware, software, and service components. Now I want to come back to the initial concept of flexible automation. It can be said that by introducing the mentioned technologies, like plug and play and scientific data standards, the automation efforts can be reduced while providing flexibility. A standardized communication protocol combined with an actual data standard and visual programming allows a simple and intuitive integration while offering exchange of actual equipment or recipes. As a take-home message, I want to state that flexible automation is already feasible. The technologies to reach this automation flexibility are already out there. The community has to work together to incorporate all introduced technologies into the R&D and manufacturing environment. Here I would like to use a common phrase which states, standards are not born, they evolve until they are widely accepted and become a standard, to highlight the importance on working together on solutions. Concludingly, it can be said that all stated biopharma demands can be tackled by introducing flexible automation. Flexible automation can be achieved by relying on emerging technologies, which include the introduced plug-and-play capabilities, scientific data standards, as well as visual programming and low-coding tools. Generic applications and workflows are a key driver for efficiency in all areas. By reducing the development effort to a single software application which is capable of serving diverse purposes. This includes all tasks in commercial and R&D bioprocessing. This is not limited to robotic automation, and does equally apply to data-driven knowledge extraction via machine learning approaches. The removal of repetitive and tedious data wrangling tasks allows scientists to focus on creative solutions for complex problems again. Business value can be created by democratizing tasks which were previously performed by subject matter experts such as data scientists and IT integrators. These concepts enable the evaluation and rapid integration of new equipment and technologies. They facilitate the change of scale in commercial production environments and allow the fast prototyping of an R&D laboratory workflow. One remark in own matter. Sartorius is actively promoting the presented concepts by supporting various consortia, startups, and academia. We are welcoming interested parties in our corporate research open spaces in Boston, Göttingen, Ulm, and Ymir. Last but not least, I want to thank you for your attention and hope you enjoyed this presentation. I wish you a great conference. And in case you have further questions, don't hesitate to contact me.